our next topic here is polynomial interpolation. And this is going to be different from polynomial regression. With polynomial regression, we had our data, and we were trying to come up with a polynomial that most closely fit it. Okay? It didn't necessarily go through any of the points. Okay? But is what we'll be doing here is we're going to create a polynomial that does go through every point. So if we were doing linear interpolation, we would need 2 points because a line requires 2 points. If we were doing quadratic interpolation, we'd need 3 points. And for instance, since we have 4 points here, we'll be fitting this with a cubic. Let's go ahead and write down maybe what that cubic might look like. So how about y is equal to a1x cubed plus a2x squared plus a3x plus a4. And now we have a couple options from here. One is we could plug in the corresponding x and y values, and this would give us 4 different equations. For instance, let me just switch colors here. If we were to plug in x equals -1 and y equals -4, we have a1, and then if you cube -1, well, that's -1. And I'm actually even going to write this in the other order. I'm going to say minus a1. And then if you were to square -1, that just gives you 1, so plus a2. And then minus a3 and plus a4. Let's do the same thing with x equals 1 and y equals 7. So we'd have 7 is equal to, and then if you cube 1, you'd get 1. So we'll have a1 plus and a2 plus a3 plus a4. Okay. And then we'll plug in the next set of points, 3 and 4. So we'll have 4 is equal to, and we'll have 3 cubed, so that's 27a1 and then plus, and then we should be squaring 3, so it's going to be 9a2, and then plus 3a3 and plus a4. And you might already see where this is going. We're about to have a system of 4 equations with 4 variables. And let's just write in our last one here. It should be 1 is equal to 125a1 plus 25a2 plus, if we were to do the next one, it would be 5a3 and then plus a4. Okay. Yeah, a system of 4 equations and 4 variables. Right? If we were to write this in matrix form, it would look like -1, 1, 27, 125, 1, 1, 9, 25, -1, 1, 3, 5, 1, 1, 1, and 1, and then times a1, a2, a3, a4 is equal to -4, 7, 4, 1. But I want to point out something that we could have done here that would have been kind of clever if we were in MATLAB. Okay. So notice that everything in this column was us cubing the x values. Okay. Everything in the next one was us squaring the x values. Okay. And then just the x values themselves. -1, 1, 3, 5. Look, -1, 1, 3, 5. And then after that, just all ones. But we could have formed this matrix just by making x into a column vector And then we could have just said x cubed, x squared, x, ones, and again, x has 4 elements in it, so I could just do 4 by 1, okay? And that would form this matrix A. So let's go into MATLAB and give this a go. Let's go ahead and start by plotting these two, this x and y. So plot x, y. Hold on. And then let's go ahead now and set up that system. So we had some matrix that was formed by doing all the x's cubed. And you can already see I already have x in here written as a column vector. Right? This right here gives us the transpose of all this. And so I wanted x cubed and then x squared and then x, and then we'd also like a column vector of ones, so 4, 1. So there's A, and is what we were solving, the system that we were solving was really A backslash B, and we were using little a's, A1, A2, A3, A4 for the coefficients, so let's just set this equal to little a. All right, and then let's choose the x values that we're going to want to plug into our polynomial. We're going to want to plug in more than 4 points, so linspace, and it looks like our x values, if you look at the little x, they go from -1 to 5, but let's just make sure we're plugging in a few more points. How about 25 points to plug in? And then big Y is equal to A of 1 times x to the 4th, or sorry, x cubed plus A of 2 times x squared plus A of 3 times x, and then finally plus A of 4. And I just want to make sure I capitalize that x. There we go. And let's plot it. Plot big X, big Y. Oh, I put B here? I meant to put the Y here, right? We had our matrix A times the little a's equal to the y vector. So this should be big A backslash y. There we go. And you can see our polynomial goes through our points, all 4 points.